Hey guys, here's the spiral review for spiral 11. First off, we got a lovely quadratic. This looks like something that is probably quadratic formula with a is equal to 4.95, b equals negative square root of 3, and c equals 5 over 33. So in setting this up, we got a is equal to negative the square root of 3, so that's plus the square root of 3, over 2 times 4.95, which is going to be, I don't know, like 9.90, plus or minus the square root. B squared is going to be 3, minus 4 times 4.95 times 5 over 33. I'm going to get my calculator out for that, because I'm not doing that in my head. So we got 4 times 4.95 times 5 over 33, which happens to be, oh, that's exactly 3. 3 minus 3 is 0. Wow, that's weird. So that's over 9.9. So this is really x equals the square root of 3 over 9.90. And that's 0 for that whole second part. That's kind of bizarre. I wonder if someone chose those numbers on purpose. Huh, must have been a pretty awesome guy. Next up, we've got pi x squared minus 1x plus 1 is equal to 0, just because I like torturing people. That's why I do this. Again, I'm probably going to quadratic formula this, so this is a is equal to pi, b is equal to negative 1, and c is equal to positive 1. All right, so we got negative 1 over 2 pi plus or minus the square root, b squared would be 1, minus 4 times pi times 1, all over 2 times pi. That would end up being something with an imaginary component. I'm not going to go there, because we really don't want to deal with that, and this is torture enough, so I'm actually going to leave this as is and call it a day. Third problem, we've got 3x squared plus bx plus 12 is equal to 0. And we want to know that there are two imaginary solutions to the equation. Okay, so I got to think about this. We know that quadratic formula-wise, this is negative b over 2a plus or minus the square root, b squared minus 4ac all over 2a. Furthermore, we know that the imaginary part is going to come from this, and that's going to happen if this is less than 0. So if b squared minus 4ac is less than 0, we have imaginary solutions to this problem. And hey, that's kind of what we're really looking for here. So we're going to set this up. B is b. Oh, that's cool. So b squared minus 4 times 3 times 12 is less than 0. Okay. So we get b squared, 4 times 3 is 12, 12 times 12 is 12, 144, minus 144 is less than 0. So b squared is less than 144. When I take the square root of both sides, I'm going to scroll up again because, why not? We end up with b is less than 12. That's plus or minus. It also means that b has to be greater than negative 12. So we're really looking at values between negative 12 and positive 12. That will give us a smiley problem. And we'll make b less than, or make the whole thing that we call the radicand. These numbers are also called the discriminant, would end up giving us something less than 0 in imaginary solutions. Next up, we've got some imaginary problems. First of all, we've got 2 plus 13i times 4 minus 11i. We got some lovely serenading going on by some crazy students who are now in the video.
Oh, I'm on your awesome video?
Yeah, we got Russell and we've got Quinn and some other people.
You'll be on Mr. Thompson's video.
Cool. Anyway, so here we're going to do some distribution. 2 times 4 is 8. 2 times negative 11i is negative 22i. 13i times 4 is plus 52i. And 13 times negative 11 is going to be negative 143i squared. That was another person saying hi. When we combine these things, we get 8 plus 30i. That's going to be plus 143 because I squared we know is really negative 1 in disguise. So we get 151 plus 30i as our answer. Finally, for these problems, we've got 3i times the quantity of I plus 2 times the quantity of I plus 3 times the quantity of I minus 5, and then 3 parentheses closing that out. Let's work from the inside out. So we're going to have 3i minus 15. I'm going to rewrite this. So I plus 3i minus 15. We've got the 2 plus I, 3i in front. I think I put an extra parentheses in there, but that's okay. I'm also going to combine I plus 3i to make that into 4i. And then do the next thing. 2 times these guys. That's going to be 8i minus 30. I've got plus I here. Those are inside the parentheses. 3i. And I might do the same thing I did before. I plus 8i is going to be 9i. Okay, we're going to distribute again. 3i times 9i is going to be 27i squared minus 90i. 27i squared is really negative 27 because we know that I squared is really just negative 1 in disguise. So 27 minus 90i is our final answer. And that'll do it for the first part of the spiral. Hey guys, this is Spiral Review for Spiral 11. We're going to start off with quadratic models and exponent rules. First up, we've got another free fall type problem. I'd like to remind you again that you're given this equation, which basically we just have to plug these values in for. So if we're looking at this, we've got a baseball pitching machine that's being launched upward at 75 miles per hour off the ground. Okay. This is not actually a greatly worded question because 75 miles per hour needs to be converted into feet per second. So I'm going to instead say this should be in feet per second to simplify our work here. So 75 feet per second off the ground. And if I take a look at that, that means that my initial velocity, we say v sub 0 is 75. Off the ground means that my initial height, h sub 0, is going to be 0. So my equation would become h of t, in other words, the height based on time, not h times t, but h of t, is negative 16 t squared plus 75 t plus 0. Okay. After how long will the ball hit the ground? Well, we know the ball starts on the ground, that's 0, so it hits the ground when it comes back to 0. So 0 equals negative 16t squared plus 75t. Okay? I can do some factoring, and I get t multiplied by negative 16t plus 75. All right, that means that t t equals 0. And for my other part, I get 16t is equal to 75. In other words, t is going to be 75 over 16 seconds when it hits the ground again. And just to remind us, the shape of the path is going to look like this. Here's 0. Here's 75 over 16. And the maximum is always going to occur halfway through. In other words, at the vertex. So if I'm looking for the maximum height, the time that's going to happen is going to be 75 over 16 divided by 2, or otherwise known as 75 over 32. Okay, to find the height, I've got to find the time plugged into my equation. So h of 75 over 32. And again, this is not multiplied. This means we're plugging in that number. So we've got negative 16, 75 over 32 squared, and then plus 75 for the v sub 0 and 75 over 32. I don't have a calculator on me at the moment, so whatever that comes out to is going to be our answer. For the sake of time, I'm not going to do that by hand. Exponent rules. We got to start with our number 1 here. X squared over x to the 7th. We know we're going to subtract that. So that'd be x to the negative 5. In other words, 1 over x to the positive 5. You might also notice you could have subtracted up 7 minus 2 and kept the 5x on the bottom. Second one, x squared over x to the 1st. Y cubed over y squared. 2 minus 1 is 1, so x to the 1st. 3 minus 2 is 1. xy is our answer. Third one, we've got 6x squared y to the negative 3, all to the 2nd power. I'm going to deal with that first. 6 squared is 36. X squared squared, 2 times 2 is 4. Y to the negative 3 to the negative 2 is going to be negative 6. And then we've got 3x y cubed to the negative 1. So I'm going to write that as the reciprocal of itself. So 1 over 3x y cubed. Okay. I know this first guy I could write as over 1. So I could really treat this as 36 x to the 4th y to the negative 6 over 3 x y to the 3. 36 divided by 3 is 12. X to the 4 divided by x to the 1 is x to the 3. Y to the negative 6 divided by y to the 3 is going to be y to the negative 9. And finally, let's get rid of that negative exponent. We end up with this as 12x to the 3 over y to the 9. All right, last, we've got 8 times 2 is 16. X squared times x to the 5th is going to be x to the 7. I'm adding those exponents. Y to the 5, y to the 3. It's going to be y to the negative 2. To get rid of that negative exponent, we're going to write this as 16x to the 7 over y squared. Next up, we got the polynomial basic section. I'm going to basically be either combining like terms or distributing on the left. On the right, I'm going to be sketching some polynomials. Okay, first up, 5x squared minus negative 8x squared is going to be 5x squared plus 8x squared, or 13x squared. Negative 7x minus negative 2x is going to be minus 5x. And 8 minus 13 is going to be minus 5. Second one, 13x to the 5th doesn't have anything matching, so I'm going to keep that by itself. Negative 3x to the 3rd minus 4x to the 3rd is negative 7x to the 3rd. Plus 2x minus negative 7x is plus 9x. And minus 1 minus negative 3 would be plus 2. Again, those are just combining like terms and being careful with your signs. Then we got some distribution going on here. 2x times 3x squared is 6x cubed. 2x times minus 2x is minus 4x squared. 2x times 4 is plus 8x. 1 times 3x squared is 3x squared. 1 times minus 2x is minus 2x. And 1 times 4 is plus 4. All right, 6x cubed, nothing in common. Bring it down. Minus 4x squared plus 3x squared is going to be minus 1x squared. Plus 8x minus 2x is plus 6x. And then I've got a plus 4. That's our final answer. Next one, same thing. 3x squared times 4x is going to be 12x cubed. 3x squared times minus 1 is minus 3x squared. 2x times 4x is plus 8x squared. 2x times negative 1 is minus 2x. Minus 2 times 4x is minus 8x. And minus 2 times minus 1 is plus 2. Bring the 12x cubed down, it's by itself. Then we've got negative 3 plus 8 is 5x squared. Minus 2 minus 8 is minus 10x. And plus 2. For number 10, we got to sketch a graph of this polynomial. I'm going to zoom out a little bit. And first thing I'm going to do is take a look at my zeros. They all have a multiplicity of 1, so these are all going to be straight on pass-throughs. This is positive out front. I'm going to predict my graph looks like a W with 4 times that it crosses. Let's find some of these points. My x-intercepts are going to be 5, negative 2, negative 1, and positive 7. My y-intercept, that's when I plug in 0 for x, I get negative 5 times 2 times 1 times negative 7. That looks like it's going to be at positive 70. All right, so I'll put my y-intercept in, make sure I mark how high that is. Then I'm going to go, well, there's negative 1, there's negative 2, and then I've got to go to 5, 1, 2, 3, 4, 5, and 6, 7. All right. I've got to go through my y-intercept to make a nice smooth curve to each of the points on the other side. And then find a way to get back up. Those are the only places I can cross the x-axis. And what do you know? That looks sort of like what I predicted. As the last piece, I'll talk about the end behavior. As x approaches infinity, y is approaching infinity here. In other words, we're rising to the right. And as x approaches negative infinity, y approaches positive infinity. In other words, we're also rising to the left. Last one of these. A couple things going on. First off, I've got 1 of the multiplicity 2. That's going to be a bounce at this location. I've got 1, 2, 3, 4 things, so I should have some kind of a W. The negative suggests that my W will be going down. And let's see what we get out of our graph. All right, x-intercepts. Negative 5, negative 7, and 7. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. I'm just going to write bounce under my positive 7, 1, just so I remember when I go about and graph this. Now I need the y-intercept, so that's going to be negative, plug in 0 for x, 5, 7, negative 7. When I multiply these together, negative 5 times 7 is negative 35. That times 7 is going to be positive 210, 245. And actually, this should be negative 7 squared. So that's going to be positive 245 times negative 7. It should be something like negative 1778. And don't worry, I didn't do that magically in my head. I got a calculator for that one. So negative 1778. From there, I'm going to draw in my nice smooth curve to my next points. The bounce here means I'm going to hit that point and bounce off to go this way. No bounce means I'm going to slide through, go to my next x-intercept. I can't go anywhere else as far as x-intercepts. I predicted a W upside down. I got that. The end behavior is x approaches infinity, y approaches negative infinity, or it falls to the right. And as x approaches negative infinity, y approaches negative infinity also. In other words, this falls to the left. Next up, we got some polynomial division and some factoring stuff. This is our new section. I'm going to talk first about the division stuff. First thing we got is x squared minus 2 dividing into x to the fourth plus 2x squared minus 8. First thing I notice is that this is an x squared. I cannot use synthetic division for this. I have to use long division. And I'm going to rewrite this as x squared minus 2 dividing into x to the fourth plus 0x cubed plus 2x squared plus 0x minus 8. Okay, that's just to make sure that I have placeholders there for x cubed and x. In this problem, I'm not going to end up using those, but I want to make sure that they're just in case I need them. Okay, I'm looking for what multiplies to get from x squared to x to the fourth. That's going to be x squared. When I multiply that down, I've got x to the fourth, and then minus 2x squared, which doesn't actually go under here, so I'm going to put a block there, minus 2x squared. Okay, I'm going to subtract that. X to the fourth minus x to the fourth is 0. That doesn't matter because that's 0 anyway. And then we've got 2x squared minus negative 2x squared is 4x squared. Okay, to get from x squared to 4x squared by multiplication, I've got to multiply by 4. Before I do that, I want to break down these guys. 0x minus 8. Alright, so this should be a plus 4. Multiplying that down, we get 4x squared and then minus 8. So that's 0x minus 8 goes under the 8. Subtract, I get 0 and 0. Which means I don't have a remainder. The second question here asks if x squared minus 2 is a factor of x to the fourth plus 2x squared minus 8. And I'd like to think about this. Okay, so when we divided this, we got no remainder. Since we got no remainder, yes, since there was no remainder. Remember that if something is a factor, it just means that it's divisible. All right, next one we got x minus 2 being divided into a polynomial. Since this is an x minus 2, I can use synthetic division, so for this one I will. And I'm going to set this up. I use the opposite of minus 2, 2 out front. I write my coefficients, there are none missing, cubed, squared, x, and negative 8. First thing I do is I bring down my first term, and then I multiply 2 times 1 is 2. I add, negative 2 plus 2 is 0. I multiply, 2 times 0 is 0, and then I add, 4 plus 0 is 4, and then I multiply, 2 times 4 is 8, and then I add, negative 8 plus 8 is 0. I'd like to remind us that that last number is always the remainder. So we have remainder 0. We've got 4. This should be 0x, so I'm going to just skip that. Then we're going to have 1x squared. So when we divide this, we got 1x squared plus 4. So that means that x minus 2 is a factor. And more importantly for this question, if x minus 2 is a factor, we need to know that x equals 2 is a 0. And so the answer to that last thing is yes. Since x minus 2 is a factor, x equals 2 is a 0. Alternatively, you might remember that we talked about the remainder theorem, which told us that if we plugged in 2 we get the same value as if we divided by x minus 2. So we got 0 as the remainder. If I plugged in 2, I'd get 0 as an answer, which is why that's a 0. Last stuff, we've got some factoring. First thing I always want to do if I see factoring of a cubic, or if I see a cubic in general that I know I need to factor, I'm going to try factoring by grouping. This is by far the easiest method to factor this, and if I can do this, I don't have to do any other crazy methods that we haven't really gotten to yet. I'm going to get x squared pulling out of those two, and I've got an x plus 2. I can take a minus 9 out of my second 2, and I'm left with x plus 2. This is going to factor into x squared minus 9 and x plus 2. X squared minus 9 is factorable. If I'm trying to factor this completely, it's important that I go a step further. X squared minus 9 is a difference of two squares. So I'm going to write difference of squares. And just to remind you, if I've got x squared minus a squared, that's going to factor into x plus a, x minus a. So in this case, I've got x squared minus 9. 9 is 3 squared. I could write that as x plus 3, x minus 3, and then I've got an x plus 2 from up there. This is my fully factored form of that expression. This last guy, if I take a look here, I've got x to the 4th and an x squared and then nothing. This is going to be a quadratic-like. And it's quadratic-like because that first power is twice as big as the second power. We've got just a number at the end. So I'm going to do my a times c, so minus 64 x to the 4th. And I'm going to add up to 12. Two things that multiply to negative 64. X to the 4th and add up to 12x squared. That's going to end up being positive 16x squared and negative 4x squared. Okay, so we've got x to the 4th plus 16x squared minus 4x squared minus 64. When I go to factor this, I get x squared out of the first two. I'm left with x squared plus 16. I can take a minus 4 out of the next two. And I'm left with x squared plus 16. That's going to turn to x squared minus 4 and x squared plus 16. This is the difference of two squares. That's going to be x plus 2, x minus 2. We don't have a rule for sum of two squares, so that's going to stay as x squared plus 16. And at this point, we are done. That is fully factored.